Yes, good evening. So today we are going to discuss about one more transformation, okay, which has to be applied under data sets, what we have, right? So in previous three videos, we discussed about data cleaning, right? And also data transformation and all under how we have to write a code in a structured manner, okay? These three are the major things are covered in the previous three videos, okay? Today in this video, we are going to see the yeah. Okay, sorry. So today we are going to discuss about some of the transformation, not some, only one transformation. Okay, actually those are the two transformation need to apply, and I merged into one single transformation that has to be applied on prescribed data set. Okay, and later on, whatever the data frame, whatever the final data frame we created for the part 3 video and also for today's video. Okay, we have to keep the data frame as a file, okay, in a separate folder, right? Understand, right? We have a data frame and we need to convert the data frame into a required file. That may be a Parquet file or that may be ORC file according to what organization decide or according to our project, right? So that is for today. We have to apply transformation on prescribed data set, and then we need to transform the data frame into the file and save it in a separate folder. That is the today's agenda for us. So let's begin then. So this is the transformation condition what they given for us. What they are saying: apply filter condition on prescribers only from 20 to 50 years of experience. That's good. As well as rank the prescribers based on their TX underscore CNT for each state. So let's break this statement. What they are asking for, let's go to top. Okay, this is the prescribed data set, right? A prescribed ID, prescribed last name, first name, city name. Okay, what was the first condition? Filter years of experience, 20 to 50. Okay, then what they stated. Also, we need to rank the prescribers according to the total CNT and for each city, right? So let us deal like this. Okay, let us take the state. In India, we have almost all 29 states are there, right? So in 29 states, we have the n number of cities. In those cities, we can assume n number of Apollo branches are there. Now the condition states that we out of 29 states, I need to get the rank, okay, of top 5 Apollo branches. Okay, nothing but I need to get the details of the Apollo branch detail. I need to get the Apollo branch details who are doing very well. Okay, based on the TX underscore CNT. Okay, what was that? Need to get top 5 prescribers in each state. Okay, so we break the condition into two logical parts. The first thing is, I will open Notepad. Okay, so we already have a file called data transformation. Just wait a moment. Yeah, this was created in a previous video. Okay, in this file we are going to create another function, data report to. Okay, and we are going to write logic according to the transformation condition what they given. So let's see here. Let's define data report to, okay, pass a parameter called as df prescribed cell. Why I'm passing one parameter? Because by seeing the condition, I understand, okay, we need to apply only one transformation on the data set. That data set is a prescribed data set, not the city data set. Okay. So let us say, what was the condition? Let's do one thing. You know it, right? So we use the filter condition in Pyspark. We have the filter as an inbuilt method. Filter. Okay. We have the two conditions. Number one is what? Df dot. We have the years of experience column, right? Years of experience greater than or equal to 20. Okay. And df dot years of experience less than or equal to 50. That is the one condition. Next condition is what? Top 5 from each state. Okay. You can assume like, you can say like, DF sir, we are going to select some columns. Okay. And we are going to order the columns according to TX and count. We will get a top 5. That is not the strategy. Okay. It is not the right way to execute our code. Okay. I will show that. Okay. DF select select prescribed ID, prescribed state from a TX and CND dot order by call of TX underscore CND. Okay. Default it is ascending order. I am making it as descending order. Sir, you can think of like, sir, I am going to use the select statement and order by so that I can achieve it, right, sir? You can achieve it. But what about the ranking? He wants the rank, like PSC state TX and count. Okay. Ranking. Let us say any number like this. Sorry, state rate. AP. Like this he want. Okay. Rankings. So when it comes to the rankings and all, we have the in the analytical function that may be in SQL or that may be in Pyspark, we have the window function. Okay. Window function that are those are majorly used in the real-time applications. Okay. Window functions are nothing but analytical functions like group by and all. Right. In window function, we have the ranking. In window function concept, we have ranking, dense rank, sorry, rank, row number, etc. Okay. So there are a number of things out there: first value, last value, nth value. Okay. Let us consider these three for now: rank, dense rank, and row rank. Okay. So in window function, we have one more important thing. It's nothing but a partition by column. Okay. And which column you are going to apply in the partition. So if you say I want to apply partition on state, so that what will happen means, so if I say partition by Andhra Pradesh, so all the prescribed, all the Apollo branch details will come under single window AP. Okay. Next, similarly, TS. All the Apollo branches present in the TS will come under single window. That's why it is called as a window function. Similarly, Nagaland, okay, Tamil Nadu, Karnataka. Like that, you will get every Apollo branch details in a single window. And then you can apply the ranking condition. Okay. I hope you got it right. Why partition by? Partition by will get everything under the single window. Example, if you say partition by state called Andhra Pradesh, okay, you mentioned the column name, state, okay. All the Apollo branch details of Andhra Pradesh will come in one place. TS, Karnataka, Tamil Nadu, Maharashtra, like that. Okay. So let's discuss about rank, dense rank, and row number. Okay. Let us say name, salary. So I'm giving some dummy names. Let's define it as 25 completed, right? Yeah, 28. Similarly, for HR, okay. So this is our data frame. Okay. Let us assume this is our data frame or data set, whatever. Okay. I'm going to plot this one. Okay. This is our data set. Now in this data set, we are going to apply window function. Okay. Window function, and we'll look into the details of the rank, difference between a rank, dense rank. Okay. Let's apply the window function. So you can say like SPC equal to window dot, okay, partition by. So if I partition by department, so that I will get all the details of the employee under the single window, right? All the IT department employees related details, I will get it in a single window. So that is going to apply now, department. Okay. Now I want to rank the people based on their salary. So after partition, one more important thing is order by. Okay. Order by. Mention the column name. So default it is ascending order. Okay. And I want to give it is a descending order. Okay. Anything. Just for the demo. Right. That's good. Now let's apply the rank. So let us say result equal to, okay, and which data frame you want to apply. Let's say the df dot with the column, say rank, okay, comma, apply SPC, nothing but a window, entire window function defined in a one variable called a specific, okay, specific, right? Sorry, not specific. Define rank dot SPC, okay. Then what's going to be happen here once apply it, okay? I will show the output of the data frame. Let's copy. I will define it. ID, name, department, salary, rank, okay. IT, 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 okay. HR, HR. ID is 1, 2, 5, 6. HR IDs are 3, 4. HR 3 people are there, right? Right, HR 7. Okay, forgot about their names. So if you look at the salary of ID 1, okay, that is employee X, okay, his salary is 20,000. Okay. Salary descending order, right? I give it. Descending order, you know it, right? From top to bottom, 25,000. Okay. Next salary, 25,000 itself. Yeah, you have it right. Sorry, not 2. Let's remove this one. Okay. Let's remove ID 1 also. Sorry. Now this is the partition by condition. Okay. Now look at the salary. We mentioned salary in a descending order. Okay. We mentioned salary in a descending order, right? So the highest salary is 28,000 in IT department. 28,000. And its ID is 6. Okay. And the rank would be 1. Next salary. What was the next salary? 25,000. Okay. Now in 25,000, there are 2 people are there. ID 2 and ID 5. Okay. Pyspark will consider any of the IDs. Okay. Let's say ID 5. Okay. And its rank would be 2. Next 25,000 other people is also there. Okay. And his ID is 2. Now the rank become 2 only. Okay. Next, what was the least salary presented? 20,000. What was his ID? 1. Now the rank become 4. What happened here? In the rank, when the two numbers are same, when the two values are same, it will give the same rank and skip the next rank. Okay. Here, 3, skip. That is about the rank. Then dense rank. If you apply the dense rank, what's going to be happen means second copy. Oh, just wait. Why it is not showing? Let's type it. Okay. Now in place of rank, dense rank. So if you apply the dense rank, what's going to be happen here is, let's say ID, name, department, salary, dense rank. Okay. Okay. Partition by department. 80, 90, 90. Okay. Next step. HR, HR, HR. What was the first salary? 28,000. Rank would be 1. Next second, 25. Rank would be 2. And then next, 25. Rank would be 2 itself. Now the last one is the 20, right? And the rank is 3 here. Okay. Rank is 3 here. Here what happened? No chance for skipping. Okay. One major difference between the rank and dense rank is, in the rank, skip will happen. Okay. If we have continuously 1, 2 to 2, then the 3 will be skipped. Okay. Next thing, in a dense rank, there is no chance for the skipping of the ranks or numbers, whatever. Next, row number is there. Similarly, you have a row number concept. So let us say no skipping. Okay. If you add a row number, then it will be 1, 2, 3, 4. HR similarly 1, 2, 3. Like it's a continuous increasing value. Okay. Continuous value. Row number. So that's why for this scenario, we are going to use the dense rank. Okay. So that we will get all top 5. Okay. That's good. So I hope you understand. So let's jump into the coding part. All right. So this is the prescribed data set, right? And we have the prescribed city, specialist, drug name, TX income. So for this transformation, I'm thinking to eliminate the prescribed specialist column. Okay. That is the one column I want to eliminate that one. So I'm going to write a select query to select the particular columns. Df data report to df description set. Okay, that's fine. So let's define a window specific. Okay. specific equal to window dot partition by state, okay, dot order by what was the column, tx underscore cnt, right, dot desc in a descending order. Okay, that's cool. First of all, we need to import this module, otherwise you will get error from Pyspark dot sql dot window. Okay, import start. So all the window analytical function inbuilt methods are available in a Pyspark.sql.window. Okay. Now let's say df describe final equal to df cell. I want to select only a few columns. I am eliminating that specialist column, right? So let us say prescribed ID, prescribed full name. Also, you can eliminate the drug name also. Okay, not an issue. Prescribed state, tx underscore cnt, and we need years of experience too. Okay, and remaining columns whatever you want. Okay, these four are sufficient. These four. Okay, you can also add if you want total day supply. Also, you can add the country name. Country name is a constant, right? USA, right? Total day supply. That's good. These three are, I mean, these few are sufficient. Next, apply the filter condition. Okay, what we written in the above statement, we written it, right? Filter, instead of df you have to mention df precede say. Okay, and then what you have to write with the column dense rank, comma dense rank dot over, I need to apply over spc. Okay, so when you apply this you will get the data set like this. Okay, dense rank 1 2 3 4 5 6 7 8 9 10 like that. Okay, why? Because we have 13 lakhs records, right? So out of those 13 lakhs record, I want only top 5. So I want only top 5 means again I need to apply a filter condition. Okay, this time filtering on the dense rank. Filter call of dense rank less than or equal to 5. Okay, so this is the logical part. We have to write it up there. So here I written the same thing by adding the loggers and all. Okay, data report to prescribed select. Okay, and selecting the couple of columns, applying the filter condition and applying the dense rank condition over there. At last, finally filtering the according to density, we need to get a top 5 and then written in the data set, data frame. Okay. So after that, go to driver. Okay. And display this function. Data report, prescribed select. Okay. And for display, we have the display function, right? Display df report 2. Okay. I'm going to make this comment. These lines are additionally developed. Okay, don't worry. We are going to discuss about these things also. Okay, nothing to worry about that one. And also, I want to add one more add-on for this application, that is nothing but I want to see the process time, how much amount of time my entire application is taking. Okay, for that I am going to import a couple of modules from the time import time. Okay, sorry, from time input performance counter. Okay, so let us say start time equals to performance counter, and in the end end time equal to performance counter. Okay, and let's say login dot info total amount of time taken start time, sorry, not the start time, end time minus start time. Okay, why end time minus start time is subtracting the subtracting lower value from the higher value, like that. Okay, I want 2 decimals only. Okay, seconds. Fine. Let's run the driver. So after applying the transformations and all, now we are going to write this transformed data frame into a Parquet files or ORC files. Okay. Meanwhile, it is running. Okay, I am going to explain some concept about the Parquet files. Okay, and also the partitions. Okay, so whenever you are developing any application in a Spark, partitions are very important. Partitions. Okay. So what are partitions? Partitions are nothing but logical division. Okay, division of data across the worker. Okay, workerNodes. So I previously mentioned, right, a Spark running on an engine, okay, called as a cluster, and it have the workerNodes. Okay, workerNodes are nothing but a small computers under a big computer, which are going to share our work. Okay, whatever the code we written so far, that is going to be shared by the worker nodes presented in the cluster, and enabling and making our application run faster and faster. Okay, so in that process, I mentioned that data will be shared among the worker. Okay, this is the picture out there. So this is some part of data. This is some part of data, and this is some part of data in our data frame or data set that has been distributed over the couple of workers. Those are nothing but a partition, right? So for some files, it have the higher number of partitions. So when higher number of partitions means data processing time a little bit will increase. Okay. So to handle those logical division of data across the workers, we have repartition and coalesce concepts are nothing but operations. Okay, you can think about it. Operations to handle partitions. Sometimes due to partitions, there will be a data skewness happen across the workers. Data skewness is nothing but one worker will get higher amount of partition and another worker will get the lower amount of partitions. So to handle those, we have the repartition and coalesce. Sir, what is the use of knowing the partition? Sir, you are saying partition and partition. How I came to know, how I would come to know my data have this much amount of partition. For that one, we are going to use the one logic. Okay, that's nothing but df dot dataframe dot rdt dot get number of partitions. Okay, so by using this, you will get to know how many partitions are presented in your data frame. Okay, or 8, it will give the number 8 or 6 or 7 or 12 or whatever. Okay, so by knowing the number of partitions, it is going to be useful for understanding the distribution of data. Like I mentioned previously, I have shown you one picture, right? Data has been distributed across the workers. So by knowing the number of partitions, we can came to know those parallelism and also optimizing the performance of jobs. Like optimizing performance of jobs are nothing but, like I mentioned previously, data skewness. One worker can get more number of partitions, one worker can get less number of partitions. Okay, so by knowing the number of partitions available in our data set or data frame, okay, so by using the optimizing queries, that is nothing but repartition and coalesce, okay, we can get rid of those data skewness and bound. Okay, so let's check it out. Any error? Okay, login.info invalid format specifier. Okay, okay, so that will be covered. Okay, no problem, that we'll discuss later. Okay, this is our final data frame. This is our final data frame. Prescribed ID, prescribed full name, count name. Okay, and we want the dense rank. So you can see the state double A square. Okay, in the A square there are only two prescribers are available, Mark and George. Okay, and they ranked among themselves only. And when it comes to AE, so these are ranked in this way. Okay, okay. So here you can observe first rank is 3412, second is 2818, and the third one is 358. Okay, like that. Sorry, here 246, 125, 61, 58, and 48. Sorry, not here, this here. There is no 125 again, right? If 125 is there, we will get again 2 and the rank is 3. We have directly 61. Okay, that's fine. Or what was the trackback error? The formatting error, right? So I already practiced here. So let's print it out. Go to driver. So don't worry, we are also going to cover the multi-threading concept. Okay, multi-threading concept are going to be covered. And we are going to write our data into Hive tables and a local database. Okay, these things we are going to perform in a later on videos. Okay. You can add it to each and every file also, your wish. It's your wish. Okay. Or else I will just stop this. Okay. Instead of keeping here start time, where is it? Here it is. Instead of keeping here, keep it here. Okay. Let's run the driver. So this is for checking how much time I'm my application taking. Okay. So by seeing the time, you can came to know what are the optimistic performance, what are the optimistic way of writing the code. I can proceed in the future. Okay, like that. We'll discuss about these two things also, repartition and coalesce. Okay, repartition is nothing but in the name itself it tells about repartition. So if we have a partitions already there, uh, repartition nothing but rearranging them data. Okay, or partition data. Sir, why partition is important, sir? You said we can optimize and all, etc., etc. I am not getting into the mind. Okay. So by using the partition, what will happen when you apply partition on state? Suppose. Okay. Generally, partition will apply on date. Okay. In general. In general. Okay. So when you apply partition on state, what will happen? If you apply partition on state, let us consider India. Okay. State AP. AP state will create one another folder. Okay. TS state will create another folder. TN, KA, MH like that. Later on, if you apply the filter condition, right? I want to get the uh, count of the Apollo pharmacies presented in Andhra Pradesh. Then, due to applying of partition, you will take the less time to get the output. Without partition, what will happen? We have 13 lakhs record. It has to go through each and every 13 lakhs record, and we need to print out the data before partition. So with the help of partition, you are saving the time. That's one of the classical edge. So now the repartition, what is going to do? Rearranging the data or partition data. Suppose you have a partition called as 8, total number of partition. By using this, you will get the 8 number. Now you are going to think about like, okay, it is not sufficient. Let's check it out. Run. Pause also time. I think we are applying the wrong way. or else we write in the function y all the time. Okay, now run it again. Where we are now. So with the help of it, you will get to know only the number of partition. Okay, let us say 8. So I want to know out of 8 partitions are nothing but let's think about 8 subdirectories. Okay, for now, 8 folders. Out of 8 folders, I want to know how much amount of data I have, how much amount of files I have. Okay, inside a folder, I want to know how many files I have. For that one, we are going to use the Spark partition ID. Okay, Spark partition ID. By this formula, by using this concept Spark partition ID, you will get to know how many files you have in a folder, like how much amount of data presented in each and every partition. So it will give the output like partition ID and something called numbers. Okay, partition ID always just start with 0. Let us say 2525 records. Okay, partition ID 1, and you have 13,000 records. Okay, like that. It will give Spark partition by ID. Now, with the help of repartition, I am going to, you can observe it, right? Partition ID 0 have some amount 2525 and partition ID 1 have 13,000. You can observe there is non-uniform distribution of data happen. So to overcome this, we are going to use the repartition concept. Okay, we are going to increase the partition from 8 to 10, so that to achieve the uniform distribution of data. Okay, uniform distribution of data. Now coalesce. Okay, here we'll write to achieve uniform distribution of data across all the worker nodes. Okay. Now coalesce, what it will do? Repartition, remember, repartition used to increase the partitions, not to decrease the partition. Coalesce is used to decrease the partitions. Okay, especially used to writing data frame into files. Okay, especially coalesce will be used at that time, right? Yeah, total processor time is 65 seconds, almost or 1 minute something. Okay, that's good, not bad. We can reduce this to 65 seconds to certain 45 seconds. Okay, in further videos we are going to see those things also. Now we are covered up to this part, right? Now what was the next required condition? Next condition is need to write data report 1 and data report 2 data frames into a folder called output. Okay, in a ORC format. Okay. So WARC and Parquet are the two types of file format like CSV and JSON. Those two are there, WARC and Parquet. Okay. WARC and Parquet nearly same. Okay. So in Parquet, while we are what is the use of writing the data frame into a Parquet or WARC format instead of CSV or Excel? Because in Parquet, reading the data is very fast. Reading data very fast means you will reduce the execution time. Okay. Because why? Because in Parquet, data arranged in columnar based. While as in CSV, it is a row based. So what is columnar based? Okay, let us see. We have two columns: ID, product, price. 1, A, 2, B, 35. Okay, row based. Okay, this is the row based. Okay, now let's see the column based. ID, product, price. 1, 2, A, B, 25, 35. Okay, this is the columnar base. So when you write a query like I want sum of all products, okay, then with the help of columnar base, it will directly jump into price and it is going to get the sum of the prices. Whereas in a row based, it has to go through the 13 lakhs of records or 40 lakhs of records. Like that, continuous go on like that. Whereas in a columnar base, it will go like this. Okay, so that it makes us reading very fast. And also the size, when you return the CSV file into Parquet, the size of the file is also going to be reduced. That is one of the major point. Okay, by reducing the size, what will happen means most of the companies are going to storing the data in the cloud, right? In the cloud, the charges would be like according to the storage consumption. Okay, so when you are storing the file with huge like 200 MB, okay, instead of storing the file with actual size of 200 MB, we are reducing the size to the certain MB, any number you can, okay, let us like 50 MB or 40 MB. So the size has been reduced and the amount of cost also going to be reduced. Okay. So that is the condition, right? For that one, we are going to create a new file called extraction. Okay. Extraction file dot py. Okay. So in that, we are going to write a function extract file. Here it will take the data frame as the input for it. Okay. Not only data frame, it will also you can pass it anything like I mentioned format, file path. Okay, file path and number of partitions. Okay, header required. Why? Because when you want to again store the data frame into CSV, we want header, right, for that one. Okay, you can also use the info schema on it. Okay, and compression type. Compression types are nothing but snip. We have the compression bgip2, snappy. Okay, what it will do means it will also going to compress the size of the file. Best example, we have zip file, right? How much amount of zip file size would be? Very less, like that. Okay, so let us say I want to write a data frame, right, into a file. Data frame dot coalesce. So I want to reduce it number of pot. Okay, number of pot or nothing but, so like I mentioned previously, right, partition nothing but it is going to create a folder like structure. Like if you partition by state, AP related data would be one folder, TS related data would be one folder. Like that, it is going to split the files according to it. If you say coalesce 2, you will get two files. Okay, I will show you. Okay, don't worry. So this is the cities. That's the name. Okay. Snappy. Right. So if you say coalesce 2, you can see two files are created. If you say coalesce 1, you can observe only one file. Okay, anyway, we are going to do this one. Okay, I am showing this just for the sake. So I mentioned, right, to get to know number of partitions are presented. Okay, data frame dot or dd dot get number of partitions. Where we are now. Okay, after coalesce, write dot, and you have to write mode. Mode is very important. You can hard code write over overwrite. If you don't add mode, if you run again and again, you will get encounter an error. You will encounter with error called already folder exits. Like okay, and dot format. Format is nothing but a format. Dot save. Okay, and you need to pass the location in the file path, and the header. If header, then it would be the header required. Okay, and the compression type. Compression equal to compression type. Okay, now you will get a question like, sir, where I need to write? Where I need to write? So we have get environmental variables file is there, right? Get environmental variables.py file. Okay, there they will mention like for city data frame, I mean city parquet file, you will get city part equal to, and they will mention some part like they given output slash cities. And for the prescribed dataset, prescribed path equal to output slash cities. Okay, even though you did not created this folder called output and cities. Okay, while running your application, it will automatically create. Okay. Then once after everything is fine, you will go to driver.py file, driver.py file, and call the function extract files. Okay, extract files. Data frame df city select whatever. Okay, just for example. Okay. Data report one, right? Sorry, data report one. Data report one. Mention the format. Let us say you can also pass the JSON to, not an issue. Or for C. Okay. What was next? File path, right? File path, you will get it out from the get environmental variables. File path, comma, number of partition, nothing but number of split in the files. I want one, okay, for one, I will show you, okay. And I want required header. I don't want it. I don't want a header because it is a WRC or pocket file, and the compression type is the snappy. Okay. So by our compressing the file, okay, so that the size is going to be reduced. So I will show you. Okay. In the environmental variables, they given like this: output, cities, and prescriber. Okay. Here for now, I am deleting this folder output. That's good. And where is the file? Extraction.py. Okay. And you are going to write a separate logger for this file. Okay. And the name of extraction. Okay. In the previous video, you know how to write it. Coalesce, split number, write.mode, overwrite, format, save, everything you know. Okay. Here, no need to return anything. Okay. We are not returning a data frame. Afterwards, it's driver. Go to driver. Okay. Right now. Right. City part is equal to get environmental variable dot city part. Then call that function extract files. Okay. df1 report. Here you have, right? df1 report, which was made in a previous video. Okay. And I am making it as WRC snappy. Similarly, we have the prescribed path, extract files, pocket. Okay. And split number, I am going to mention 2. And here split number, I am going to mention 1. Generally, by saying by getting the get number of partitions and all, we have to decide, or else sometimes the seniors who are working in our project, I mean solution update, or who are working at high level, they are going to give the information for us. Okay. So here you can observe no output file is there. So when I run the application, it is automatically create the output folder and process the things. So once after completing this, we in the next video, so far we have seen, we have the source, right? In the source, we have only single files. What if we have multiple files and we have to, and the data frames, those has to create dynamically. Okay. Suppose we have the file 1, file 2, file 3. Okay. And the data frame has to create dynamically for the respective files. Right? Why? Because in a real world scenario, you won't encounter with single files. You will encounter with multiple files. Right? Forgot about their extension type, CSV or Pocket. Okay. We need to create a separate data frame for the each and every file. And later on, we are going to process that. Okay, where we are now extracting to output. Yeah, completed. Totally 101 seconds. Let's go to output. Cities. Okay, right. Where is the prescriber? Parking. Let me open this one. Okay, like this, you got the Parquet and PORC files. Okay, so with the respect to coalesce, right? In the next video, I will show you. I will show the things. Okay, how to open these things and how to look it into it. Generally, we cannot observe the Parquet file. We need to convert that into the CSVs, and then you can observe. Okay. Eh, Okay. So that's it for today's video. Okay. So what we did, we applied the transformation of prescribed data frame. Later on, we have seen uh, how to write the files into Parquet or different file type extensions. Okay. With the given part. And also we added the time to get to know the how much time my application is taking. And also we covered about a theoretical concept for partition and repartition policy. Okay. And their use cases. Okay. That's it for today's video. In the next video, we are going to write the data into high meta storage and the local database. Okay. Once after completing those concepts, we will move on to the multi-threading part. Okay. In the multi-threading part, it is going to helpful for reading the files at a time. Okay. Like I mentioned, right, in the source, you don't have any single file. You may encounter with 20 to 30 files. So with the help of multi-threading, you can read 5 files at a time. Okay. So multi-threading, you know it, right? Multiple, I mean, parallelism will work. Okay. Parallelly, it is going to execute. Once after doing the multi-threading part and all, okay, we are done with the application, and later on we will put it in a cluster, okay, with the help of the AWS. In AWS we have the EMR, right? So we will drop the our application in the EMR, and there we are going to run this application. From there we are going to run this application, not from this Python. Okay, so that's it for today's video. Okay, we'll see you in the next part. Thanks for watching.